All right. Good evening. My name is Mohit, and on behalf of Aalto University, I welcome all of you to our first event of 2021. Since this is the first event of the year and I see some new people on the call, I will very briefly introduce what HAIC is all about. So HAIC stands for Helsinki-Aalto Institute for Cybersecurity. It was founded by University of Helsinki and Aalto University in 2016. So it's a joint research initiative with three primary goals. The first is to foster joint research in cybersecurity between the two universities, as well as the industry in the capital region. The second, as you know, Finland now has tuition fees for students who are applying from outside the EU, and both the universities were concerned that this would negatively affect the number of applicants. So we reached out to our industrial partners, and thanks to generous donations from Huawei and F-Secure, we are able to provide scholarships to students who are specializing in cybersecurity. The third and final goal of HAIC, which is why all of you are here today, is that we have a public outreach program, which is funded by the Dean of School of Science. As part of this outreach program, we host HAIC talks, where we invite experts in the cybersecurity field to give enlightening talks. And we also provide you with an opportunity to interact and engage with them. So we will have sufficient time at the end of today's talk for a Q&A session where you can interact with today's speaker. Today's talk is going to be about how we can help developers write secure code. And without further delay, I would like to introduce our speaker for this evening, Yasemin Acar. So Yasemin is a research group leader at the Max Planck Institute in Germany. Her research focuses on humans, their behaviors, their wishes, their needs, desires. More recently, she has been investigating how to help developers implement secure software development practices, and her research has shown that working with developers can prevent security issues from showing up in end products and services. In the past, she has also been a visiting scholar at National Institute for Standards and Technology. She has also received the John Carrett Usable Security and Privacy Research Award in 2018, and she has been honored by the National Security Agency with the Best Paper Award in the Cybersecurity competition. Without further delay, I guess I will hand over the controls to our speaker, who will begin the talk. So Yasemin, do you want to take over the screen sharing?
Sure, thank you.
Yeah, we see your screen. Yeah, go ahead.
Awesome. Yeah, thanks so much for inviting me. And thanks for the awesome intro. As you said, today I'll talk about my research in human factors in secure development, and specifically how we can help developers write secure code. So there's this, like really common insight that the majority of all security incidents recognize human error as a contributing factor. And this human error can be committed by obviously end users, right? Like the thing that we all know and always talk about, like people choose easy to guess passwords, they reuse passwords, they don't comply with security warnings, they just click through, they click on links and emails, and they make all the mistakes. But if you go up the pipeline, you can also see that, or you also find that developers are maybe unable to use APIs correctly, or maybe using outdated libraries, and that admins don't configure systems correctly and securely, or maybe managing patches insecurely. So one really prominent example of security and how it fails to reach humans is maybe email security. So in theory, this was invented in the 90s, and we could have a confidential email where we know that it's authentic and where we know the message has not been tampered with. And in practice, what we do have, if someone wants to send a secure email, the best that we do get is that someone attaches a confidentiality notice and says, by the way, please don't share it, and like if you print it, lock it up, right? and reminds you of laws and that you shouldn't be doing this. And part of the problem is maybe that it's really hard to use email encryption, and then people are just unable to, or are even unaware. And the result is that the majority of emails that people send are not being end-to-end encrypted. Another problem that's really prominent is authentication. If we, in theory, we could have strong passwords, we could have client certificates, everyone could be using two-factor authentication or could be walking around with YubiKeys, basically hardware authentication. And in practice, what we do have is that every time people sign up to something, and especially in the recent pandemic, people, and including me, have created tens, if not hundreds, of new accounts that we previously didn't have and didn't need. And every single time we created accounts, we were prompted to create a secure, unique password. So the typical end user will then just go and maybe create one or two of those, and then at some point they run out of ideas, and then they will just do anything and everything. So these are the most common passwords. And in addition to the problem, people just reuse passwords, right? Like somewhere around 5, 10, 20, or 50, people run out of ideas, and then it's just going to be the same password over and over again. So within the security community, and sometimes within the media, the message that gets sent is, why are end users stupid or lazy? If they don't want to be hacked, if they don't want their info to be shared, if they want their privacy to be protected, why don't they just do all the right things? And this research community, the usable security and privacy community that I'm also part of in the past, has basically said, well, this is not the right question to ask. The right question to ask is, how can we make security easier for people, for end users to use, so that everyone doesn't run into the same problems and then, loses money or loses privacy or loses access to accounts. So let me quickly walk you through popular research topics within this usable security and privacy community that's so awesome. So we can see that the whole authentication password thing, these are the blue dots on the right, has received a lot of attention. So this image is basically created from looking at the research that was published within the last 25 years, and these are basically the topics that were discussed. So authentication is a really big one. And then you can also see that on the left, these are the green dots, looking at social media and overlapping also with privacy in social media, and what people can do to maybe not overshare in social media or to control who gets to see what. That's a much researched topic. And then if you look at the light blue dots at the top, these are permissions. So this could be access control on mobile phones, specifically Android, which kind of is close to the purple dots of access control. And then also at the bottom, you can see in yellow, this is phishing. So this is, where do end users, click on links and emails, and how can we prevent them? And is there any training that we can do to do better? Right next to it on the right is the orange dots, where it's warning messages. So specifically for example, TLS connections, or at the time SSL connections that were maybe not being authenticated correctly. What if you show users a warning message? Like, what are they going to do? Are they just going to click through? And is there a way that you can train them or make the warnings better so that they will basically stick with what the warning says and then make an informed decision on how to proceed? And then the brown dots on the bottom left were papers, research on location tracking. Can you do that in a way that delivers function to users, basically saying, oh, your town has this and that weather. today and next week, but not saying, and also now I know that you live in this house and you're currently, you know, walking around in your apartment. So these are basically the topics that have received a lot of attention within the community. What hasn't received a lot of attention is basically research that doesn't really target end users and their decisions. And that's kind of not surprising, right? Because the non-end users, maybe the developers, maybe the admins, they're perceived to be experts in what they do. So while end users struggle with these problems in their day-to-day life, for other people, it's their job, right? So we can basically expect the people who implement all this stuff and who make all the decisions, who are technical experts, who have maybe studied computer science, who are able to do complicated things such as programming, to, you know, do all the right things for security. But the thing is that also people who are maybe experts in programming a few things, or maybe programming many things, are not always experts in security. And they fail to use maybe even known good protection methods. And then whenever someone gets hacked, problems can become worse than they needed to be if only developers had known or had used or had, you know, done the right things at the right time. So if we have this developers are experts and know everything and do all the right things mindset, then, you know, why did we have Heartbleed, which was very interesting and prominent when I started out on this research journey, because it existed for 2 years before it was caught, right? So that was something where everyone always says, oh, open source libraries are good and everyone should use them, because in theory, people could look and could check whether everything there is secure. But in reality, a couple of volunteers, or like a small handful of people that go for functionality, may not be able to catch everything at the right time. And then in addition to maybe developers being understaffed or having too many things to do, their life may also be unnecessarily complicated. So they may be struggling with unsafe API defaults, where the default is just an insecure mode of operation in the example here, or where documentation is just terrible and doesn't really tell them what to do and which thing to pick, or where tool support may also be terrible. So this is here from back when Eclipse is used, and Android Studio is used to program Android apps. So you would just get an auto-generated code stub that essentially turned off certificate validation. So you know, you were a developer, you were trying to do the right thing, you were trying to validate a certificate that you were seeing, and then once you started fiddling with it, the auto-generated tool support code stub just gave you that you switched it off. So essentially, if you look at the thing of, you know, security is no one's primary task, and developers may be undereducated, understaffed, and it may also just be really hard for them to do, we can maybe move away from this question of, you know, everything is hard for end users, so they can't be burdened with the problem of doing security and privacy, but developers should be doing it, so why are they not doing it? And move towards, well, how can we make those people help by making secure programming easier? And this is what I've done over the last years. I've studied developers. And it comes with a couple interesting challenges. So if you think about it from an accessibility standpoint, where you know, you can get them for research studies, or you can observe their behavior, it's really easy to study end users. But as you go kind of like down this inverted pyramid, there are fewer developers and they're harder to get. And then if you want to talk to system designers who make the big decisions, who also make decisions of what can developers actually decide, what can they use, they're even harder to study and there's way fewer of them, right? For end users, you can just, back when you could walk out the door and meet people in a cafeteria, everyone was an end user of something. So at least like of the internet or smartphones, anyone and everyone you would run into was using those things. But especially depending on where you are locally, it may be harder to get a handle on developers, and then system designers may be really hard to find. But for impact that you can make when studying them, it's basically inverted, right? Because if you study a couple of end users, and I'll just do the example of you take your cafeteria, then you may know something about, the mindsets of local students who may all, be either actual local and may all have the same culture. They may all be really young. They may all be using the newest technology. Everyone has their own smartphone. And that's a small subset of what end users actually look like. So even if you understand them, or if you educate them, or if you, change their mindsets, or if you take their problems into account, you may fix the problem, but you may only fix it for a small subset of end users. But then for developers, depending on how popular the stuff that they program is, you may actually, when you work with them, be able to fix something that affects a lot of end users without ever bothering or studying the end users. And then system designers can maybe make big decisions where it's like, you know what, from now on, we're only going to deliver, secure connections, or from now on, everyone who wants to publish an app needs to do this or that. And then basically, you can maybe solve the problem without even involving developers. So if you look at the Android ecosystem, billions of people have Android phones and they're easy to find and you can talk to them. There's not a ton of developers and there's only one system designer. So so basically, the developer level is the one that I have decided to study. This research is challenging in some ways. So basically, recruiting is hard, but it also requires a level of knowledge of study design, but also of technical knowledge, or collaborating with people who do have this technical knowledge. And then the questions that we want to answer would be, how can we understand them better? What motivates secure behavior, or what motivates them to not program securely? How do they learn about security? How can we improve their information resources? Where are their knowledge gaps? Can we address these, or can we work around these? So basically taking from the end user idea where maybe it's not feasible to fix everyone's knowledge gap, right? Like where it's not feasible to teach everyone about encryption, teach everyone how to, securely authenticate. So maybe here for developers, when there are knowledge gaps, there's also a way to work around them without teaching everyone everything. And then relatedly, which organizational structures can maybe be put in place to help ingrain secure practices, right? So that it's not a one person makes one decision thing, but so that it's like maybe the company culture or even company resources that make the decisions for them. And then which do not help, right? So maybe, so for end users, it's interesting that when you run phishing tests on them, what could happen is that they would also just get like really used to every phishing email that comes is actually able to click on those links. Or maybe for developers, it's kind of the same thing, right? Like if you ding them on the same things repeatedly, but it's always a test, maybe that's also something that just overburdens them or teaches them to learn that there's always someone like looking at their stuff after they do it. And then also interestingly, how do developers learn on the job? So when I was a student, that was one security engineering class and it was an elective. So basically it was possible, like when I graduated, it would have been possible to graduate without ever learning about security. So if then I was working as a developer, I would have had to learn everything that was important for security on the job. And from talking to people, from talking to actual developers, this is also what we learned, that a lot of people learn a lot of things on the job. And then one important thing also is, what do developers think that they want or need, right? So do they need, in order to do things securely, do they need more time? Do they need more resources? Do they need more education, or do they need someone else to just do it for them? And then also a big topic in this developer-centered research is that we're trying to look at the root causes for problems. So what actually harms and helps? There's a lot of anecdotal stuff on the internet where people say, well, don't do this, this is bad, or do this, this is good. But then in practice, what actually harms or helps? There's, for example, programming languages out there that are better than others at achieving security. But in order to say that they actually do that, right, one would have to look at, well, are they sufficiently easy to use, and do they cover a broad enough set of what people may want to do with them so that they're actually being used, or are they so focused and so terrible that no one actually uses them, so they're out there, but in addition to being out there, there's maybe not much that they do help. And then another interesting root cause analysis question is where problems actually come from. So can we trace them back to some root causes, and then maybe change these causes, and then the problems will go away? And then also, how do they proliferate, right? Is there somewhere in the chain of there's a problem and then it reaches people where you can interfere and where you can maybe take this out, or where you can check? And then also in the past, what has been successful in decreasing vulnerabilities? Is this something that we can learn from and basically bring to new technologies, or is this something that just needs to be amplified more? And then in order to do all of this, we need to actually measure what's out there. So which APIs, tools, and documentation are actually being used by people, and why are they being used, right? So as security researchers, we may be thinking, well, obviously you should use this because it's secure, but I should use this because it's secure is usually not on people's mind. Maybe the reason why they use this is that it is really usable and it also gives them a result, or that they can find examples or tutorials online, and then if something is used or recommended by a lot of people, maybe this is why they use it. So maybe security is not something that plays a role in making this decision. And then if this is the case, can we make security tools more attractive in the way that they're, at least as functionally usable and useful to people as tools that may be not secure? And then how effective are security tools in practice? And I've maybe alluded to that a little bit, and we'll actually find that later in one of the studies that I'll be talking about, that there are some security tools that were designed with the best intentions in mind, but then end up not being really useful. And then for the ones that are useful, which are they, and why are they so useful? And then also what design features are effective, and which usability failures can prevent people from using something that would give them awesome security. And then because we're talking about studying people, we always have to worry about ecological validity and generalizability. So what type of study should we be using? So if we drag people to a lab, we can observe them, but then they're also working on our computers in our lab and haven't set everything up in the way that they would usually have. But if we want to observe them in their company, it's really hard for us to get in there. And then also once we're in there, to observe like the one thing that we really care about, because maybe it's something that they don't do a lot of the time. And then in these studies, and also in the pandemic, of course, right? So you can't maybe now actually go and watch people, and you definitely can't ask anyone to come into your lab. So if even if you designed a study ahead of the pandemic, where you're like, Well, for this study, it would be really useful to watch people in a lab. Now we have to be creative and think about, how can we observe people without actually having to invite them and come work here. And then when can you use students in your study versus using professional developers? So the good thing about students is that you kind of know which classes they've taken and you kind of know what they know. And also they're relatively cheap to convince to participate in your study. But usually you also only get the local students, right? So you have this extreme outlier sample of like whoever happens to have gotten into your program and in your place. Versus professionals are, of course, more diverse, but it's also harder to get them. And then especially for lab studies, it may be impossible to convince them to come to wherever you are and spend like 5 hours in your lab in exchange for like 50 euros or dollars like an hour. So that may just be incredibly expensive, but also not feasible. And then once you've decided what to do, how can you design useful study tasks? Because you want to see, all these questions of what do people know, what do they use, how do they make decisions, and you want to be able to observe that, but you also don't want them to spend hundreds of hours coding just for you to be there anxiously waiting for them to get to the one point that you care about. So you need the tasks that they have to solve to be sufficiently complex to capture useful data, right? For them to, for example, get help or make decisions or actually write security critical code. But then it also needs to be doable in this study environment where you have to pay them for their time or where they have to volunteer their time and where you're able to observe them. And then also these tasks, of course, need to be sufficiently realistic for your results to generalize, because if you have a study that kind of only makes sense for your lab setting and then that ends up producing results that have never been seen in the real world, that's really interesting, but it's maybe not explaining a phenomenon that people care about. So in my research, maybe the final important question would be, when and where in the development life cycle can we support developers, right? So if you, so this is taken from a 2018 SOOPS paper, and this is the development life cycle that we extracted from 21 interviews with crypto developers, where we asked them, well, what do you do to develop and test your code? So this would be kind of like an ideal do everything, throw everything at the problem life cycle by crypto experts that really, really care about their crypto. And as you can see here in this life cycle, there's a lot of, I want to say, redundancy, where people think about security and in every single step and test for security in every single step. So it starts at the bottom right with specifications and requirements, where the choices about resources that they use or the choices about experience that the people they hire are going to play a role, and where they have to take customer needs and standards that they have to adhere to into account, where they decide what the threat model is going to be, and then they decide how they're later going to test and maybe already implement the tests. And then as you go through the cycle, there's this development phase where they will actually develop, where it's important to use secure defaults, and where maybe the third-party resources that they have decided they will use are actually going to be tested for security or for adherence to standards, and where they may have to, develop on them a little bit or iterate on them a little bit in order for them to be okay to be used in their project. And then the next big step would be testing. So of course, that would be functional testing, but also security testing, where maybe fuzzing tools come in, and where basically the unit tests are going to be executed, and where maybe internal, external people would do code reviews, but also where, well, third-party tools may be used that do static code analysis or fuzzing and tell them about problems in their code that can then be fixed. And then as you get closer to release, they may do pen testing, external bug hunting. They may have to get certified that they adhere to standards or to guidelines. and then they would release. And then after release, a good company would spend time and resources on continuous testing and looking for vulnerabilities, and then basically inform the specifications, and then you would go through the cycle again, right? And if you think about crypto experts, this is a life cycle that makes a lot of sense. If you think about a team of like 2 or 3 Android developers sitting at home in the pandemic and deciding, well, this is a really good time to, in our evenings, to produce a new app that does X thing that will interact with users. This is not realistic, right? So the question would be, where can we take some of the effort from them, and where can we understand them better, and where can we, take some of the good things that would be in this really complete secure development lifecycle and bring that to people who may not be experts. So the studies that I will present will basically focus on decisions made and tool support in these 3 phases. So basically in the resource choice phase, and the development phase, and also in the testing phase. So the first study that I want to talk about in detail talks about the impact of information sources on code security, which was 2015-16 joint work with the University of Maryland. So this is what happened in our lab in early 2010s, when someone was working on an Android app, and they had a self-signed at the time called SSL certificate, and the app was not working, right? So the first step that happened back then in the lab was someone going to Google and asking this question, and then someone basically getting a result from a developer question and answer forum on the internet called Stack Overflow, where someone else had asked the same question, and then people would give answers and would give code examples. And the code examples would be, at the time, that you would, like I said earlier, disable certificate validation completely. So you're talking to someone and the connection is encrypted, but you don't know who you're talking to, right? So you're kind of still sending your information via an encrypted channel, but you don't know that you're actually sending it to whoever you were intending to send it to. And this is basically the online advice for, well, if you take this code snippet and you put it into your code right there where it's not working, then afterwards it will work. And it does work, right? It's just no longer secure. And at the time, a lot of apps did this, and a lot of users were affected. So anecdotally, now everyone knows that just copying and pasting code from the internet so that your project compiles and works is a terrible idea, especially for security. And the less you know, the less experienced you are, the more likely you are to introduce a problem. And our study asked whether we can measure this problem empirically, and also how random online advice from other people contrasted with official advice, official documentation. And then taking a step back at ecological validity, the study also asked, well, now that we have answered these questions, have we found something that actually happens like this in the real world, right? Like, does this that we did explain an actual problem? So what we did in this study was that as a first step, we conducted an online survey where we recruited developers from Google Play to fill in this questionnaire, where we basically asked them, well, which resources and which IDE do you use for programming? And back then, the majority said that they used Android Studio. And then also they told us about the online help resources that they went to. And then we had this knowledge in order to design a lab study that was realistic for what actual Android developers had told us that they do. So for this next step, for the lab study, we invited students and also local professional developers in the US and in Germany to come to our lab to participate in a 2-ish hour programming study that also involved them thinking aloud so that we could, hear their thoughts while they solved the problems, and we could shoulder surf what they did so that we could also see what they do. And then later we took the step back and looked at 200,000 Android apps that we crawled from Google Play and looked whether we could find the code that people had and the problems that they had produced in the study in the actual apps. So for this question, where do people find secure programming advice? This was the online survey that we did with actual Android developers. And this is what they said. So when we asked them where they look for general advice for programming in Android, the top dark green bar is that they said they look at books, and the light green bar, so around 27%, is that they use the official documentation. But the larger bars, the orange one and then the other orange one, so over 50% is that they just use a search engine, so like Google, and then they do whatever is the top result, or that they use Stack Overflow. And then specifically for encryption and for HTTPS, so this is what they said. For permissions, it was a little bit different because there the official Android documentation maybe had really good explanations. So that's where they went. But in general, Stack Overflow, so this peer-created, crowdsourced resource of one developer asking a question and then other people chiming in with possible answers and with help was the major resource that people go to. And yeah, book use was pretty rare. So, and then the question that we asked for a lab study was, well, if Stack Overflow is so popular, and does it have an impact on code security? So we recruited these student Android developers and also non-student Android developers into a lab study and had them solve tasks. And we sorted them into 4 conditions for how to solve these tasks. So one group of students was only allowed to look at Stack Overflow. One group of students was only allowed to look at a book. One was only allowed to look at the official Android API documentation, and one group was allowed to do whatever it was that they wanted to do and look for advice wherever. And then we gave them 4 short programming tasks that were each designed to have a secure possible solution, but also an insecure possible solution. And yeah, put these people into the conditions. And then in the end, we gave them an exit interview. And the programming tasks were given to them in randomized order so that they didn't have learning effects. And the study took about 2 hours. And we did not tell them that we cared about security or privacy. This is what the study looked like. So they could test it in an emulator. And these were the tasks. So the first one asked them to implement secure networking. We gave them an app that had, basic functionality, and one of the basic functionalities was that it was talking home via HTTP, and we wanted them to change this to be secure, or basically to use HTTPS. And then if they managed that, they would see a certificate error. So it's a subdomain problem in this certificate error. The secure solution would be to look at the cert and then say, well, okay, if this is where I want to connect, I'm going to accept the certificate and basically pin it. And the insecure solution would be to turn off certificate validation. The second task was for them to implement inter-component communication in a good way. So we said, you have the service and you want other apps to be able to use it, but only apps from the same developer. And then for that, Android has a secure solution, which is to define a signature permission, which then says, well, all apps that have the same signature, which are the ones that come from the same developer, can use the service and everyone else can't. but the insecure solution would to be exported publicly. So this works, right? Because the apps from the same developer can access the service, but also so can any other app. The third task was secure storage. So they were supposed to store a user ID and password locally and persistently, and the secure solution would be to use Android's private shared preferences, and an insecure solution would be coming up with their own thing and then somehow storing it publicly on an SD card. And the last task was to adhere to the least permissions principle. So they were supposed to dial a customer support phone number, for which the secure solution would be that the app just dials but doesn't call, for which it doesn't need an extra permission. And the insecure solution would be to actually call, which can incur costs and which needs an extra permission. So the dialing would basically be you enter the number and then the person still has to click so that they want to call, and then they make the call themselves, and the insecure one would basically be the app calls. So if we look at functional correctness of the tasks, the hardest one was the secure networking one. So only a third of the participants got this to work at all. And then the easiest one for the solution to work in some way at all was the least permissions one, where it was 87% of people that somehow got it. If you now look at the colors, so orange would be Stack Overflow, and the yellow would be the book. Those were the ones that were best at producing functionally correct solutions. So basically, in a company where your boss says, I want you to do this, and I want this to work, these are the people that achieved that goal. And then the people who were constrained to using only the official documentation were worse at this. And this was significantly worse than Stack Overflow. But then if you look at security, Stack Overflow performed worst. And then in blue, the official documentation people were best at achieving security. So we have this problem where on the one hand, the resource that most often gets you to solve your task is also the resource that gets you there in only half of the cases to do the security, right? So basically, if you go back here, so 70-ish% of the Stack Overflow solutions were somehow working, but only half of them were secure. So now we've produced a huge chunk of code that on the surface does what it's supposed to do, but behind the curtain isn't doing it securely. And then we have the official documentation where it's like, well, if you are able to solve the problem at all, you do get a secure solution, but you may never get there, right? And then what's the solution to this, right? We kind of drew the conclusion that if you want functional but also secure code, what you have to do is cut off the internet and give your developers the book, because this was the best of both worlds, right? Like functional and also secure code, which of course is funny to say, but it's also not realistic. So the real takeaway is that if developers use Stack Overflow and have access to it, which nearly everyone does, they will get quick functional solutions, and official documentation for Android at the time doesn't get you there. But then these solutions are actually less secure than official documentation generated or helped results. And so we need resources that integrate both. And also if we look at our control condition in the study and basically what people do in real life, and basically pulling the question back to company policy, right? If your company policy says you're not allowed to do X thing because it's not secure, or where they say, please use this resource only because otherwise your results are not secure, in a real world setting, you're not just going to quit, right? At some point you're like, well, I cannot solve X problem using Y resource, so I'm going to Google the problem, and then whatever gets this to work is the thing that I'll try. And then if I have additional time, or if I have awareness of security problems, I may go in and like try to fix them later. But it's just not realistic to expect people to do something or stick to something that's A, frustrating, and B, doesn't give them results. So basically, what we ended up with is that some things are just hard, and developers need the best possible support in order to be able to do them at all and do them securely. And this is the second big study that I want to discuss and want to talk about, because it gives us such a great insight in just how hard crypto is for developers. So if we think back to this mindset of, maybe they're just not motivated. Maybe Android app developers just don't care enough about crypto in order to invest the time and effort and knowledge to be able to do it correctly. So maybe it's a people problem, right? So you could come from that perspective, but then you will very quickly move on from that perspective if you see which types of people also fail. So there was a couple years back these hilarious news about how people that develop ransomware, so that they're basically being criminals by way of doing crypto correctly. And these people also fail, right? So if it's a motivation problem, I think the motivation of I want to be a successful criminal and I want to make money and I also do not want to go to jail, you can't be more motivated than that, right? So so if these people basically can't get it right, it can't be well, they just didn't care or they didn't care about the product problem. Luckily, well, maybe not luckily for ransomware people, but luckily in general for the community, some crypto API designers or crypto API developers have seen the problem and have designed APIs that are specifically meant to be usable. So at the time, Lipsodium and Kezar is by Google, were two of the libraries where everyone was like, well, these are more usable because we made them to be more usable. And more usable here meant that it's simpler to use them. So they came with a limited set of what you could do and also could do incorrectly. They came with secure defaults, and they had fewer methods that you could call. So if we think back to this like terrible defaults example or this like terrible documentation example, well, this is supposed to solve that. And our research question, now being aware of these, was, well, do cryptographic APIs that are designed for usability lead to better security? And this time, our method to look at the problem was an online study with Python developers. And that we moved to an online study was in part motivated by the question, well, our last result was produced by local students. Those were local students in three regions, actually, 2 regions in Germany, 1 region in the US. But we were also unable to get a lot of professional developers to participate in our study, just because locally it was just hard to get them with the correct experience level for our study. So in an online study, of course, we could reach more people because we were not limited by who could physically be with us. But it also meant that we couldn't observe them. So in the last study, we were able to observe people. And we were, for example, able to observe that very, very rarely anyone loudly talked about or specifically searched for security, and that they dismissed comments about security that they found online. So in this study, we wouldn't be able to see this. And then we chose Python as the language in which we conducted the study, because there are many developers that use Python. At the time, it was like what, the 3rd most popular programming language. I think it's now more popular. And they had bindings to all of these important APIs that are especially designed for usability. So we picked 5 crypto libraries for Python. And then in our study, again, as a condition, we put people into groups where they could only use 1 library in order to solve tasks that we gave them. So we gave them a symmetric set of programming tasks and an asymmetric set of programming tasks. And here we ran into a couple limitations because not all of them could be solved with every library. So in some cases, it was just not doable to do the task. And then again, for the others where we did have solutions, they could either be secure or insecure. And later we manually evaluated functionality and security. This time we did this in an online study environment with an exit questionnaire where we asked people about, do you think you were successful? Do you think you achieved functionality? Do you think this is secure? We gave them something that's called the SUS. So that's the system usability scale, which kind of asked, we're happy with this system. Would you recommend it? Would you use it again? Which was not perfectly appropriate for a library. It was more like for a software system. And it also didn't help pinpoint which was the problem, because while I wouldn't recommend it to a friend, it's not really helping us pinpoint what the problem is. So we also gave them more questions that basically asked where the problems were with using the APIs. And then again, we collected their experience and their security experience. And we recruited from GitHub developers with Python experience. We were unable to pay them because they were wherever, and we couldn't just send people checks at the time. Now I think with gift cards and PayPal we could. And we had 250-ish valid participants, and a lot of people who were interested at some point quit the study. So if we look at our results by API, the bottom three, the one with the yellow bar, are the ones that were specifically designed with usability in mind. They were not, overall the most successful. So the bottom, the top two are not specifically designed for usability, but PyCrypto is the most, at the time was the most common one. And these were the ones where people were able to find code examples online, and where we could see in our online study that they copied and pasted code, and that helped them significantly to solve the task functionally. Whereas this one here, which was the internal Google library, didn't have this. But then if we go for security, it's basically the same thing inverted. So for these two top ones, we found that the code was highly functional, but low in security. And that for the one, where it was incredibly hard to get a solution at all, we had very secure results, but it rarely worked, right? So in the real world, again, we have this thing that's like really good at getting people results, but a large chunk of these results are then going to be not secure. And we got decent results with two of the libraries at the time that were designed for usability. And then from our questions that we asked, and also from what we observed in the code, we did find that usability helped with functionality, but that just saying, well, we designed for usability, that didn't necessarily lead to a good usability rating and to good results. But good documentation could differentiate. So where people copied and pasted code from really helped, right? If the documentation was good and they could go there and they could copy from there, then they were likely to be successful, but also secure. So the most successful library gave low-level functionality, but with really helpful documentation where people could find help. And then this combination gave also the best combination of functionality and security results. And also we found, again, that full functionality is important, because in the real world, like, who are going to be the people who stick it out with something that's like terribly usable and also doesn't have a lot of options, so that for other tasks you have to revert to something else. So in real life, if you don't have full functionality, people are just not going to use it. Looking at experience, the experience level did not matter, and the security background kind of mattered, but was basically trumped by what you could do with the library versus what you wanted to do with security expertise. So this is the second big study that basically showed us that documentation is important and usability is important, and that also that there are some tools out there that have figured out documentation, have figured out usability, and that if use was increased, that this could actually help fix some problems. So I'll very briefly talk about some other fun things in this space that we've done, and I'm happy to chat more about them later. So one would be, if you think back to the development lifecycle, you've now moved more like to testing or more like to development, and you've moved away from these like resource choice. There's tool support, right? So back in 2017, we tried an Android Studio plugin that would help developers write more secure code by basically flagging, highlighting, and warning about problems, and then giving them really easy, quick fix solutions to problems. So with many of the low-hanging fruit of problems that people always create, we were actually able to get people to implement these quick fixes and to do better with this plugin than without this plugin. And that was before I think there were stuff like this was used in industry, but now stuff like this is actually marketed to companies and is actually used in industry. So it looks like this has moved, or well, this was shown to be effective in a lab, and then like later someone or multiple companies developed this into an actual product. So it's like not this, but this idea into an actual product. And it seems to, at least for low-hanging fruit, this seems to work. And then in another study, we found that if we went to Stack Overflow and took all the code snippets and then, decided which of them were secure, we were able to actually quantify how many of them ended up in Google Play apps. And we found that a lot of them actually did. So that this problem that we saw under lab conditions was actually a problem that really affected the ecosystem and not just wasn't just confined to a lab study. Another interesting study and basically a teaser for like a whole group of or for a whole host of research that could and should be done is what do we get when we use different developer sets in security developer studies? So in one of our sample exploration studies, we compared professionals with students and found that, being a professional or being a student was not the main thing that led people to make different decisions, but that it was generally how much experience they had. In the study, it was Python. So in Python in this study, experience mattered. But this is just one of the things, right? So we're basically now creating a body of research where we study developers or students, and the people we study, and that's not just us, that's like basically a lot of the people who publish in this field are usually men, and then they're usually recruited in the US or maybe in Europe. So that's a small subset of the people who actually write the code that everyone uses. And then, in another study, we found that company security culture actually helps people develop security mindsets. And then people who have security mindsets who join companies will help develop a company security culture. So this is actually a cool process that we can observe in the wild. And like one of the questions would be, can we bring this into university education? And then participatory research is also really interesting. So in one other study, we co-designed warnings with developers and found that what we thought was a fantastic warning that would be really, really helpful, we thought was actually not something that people wanted. And they basically wanted to be less overwhelmed, have less information at all the time, at the time of compiling. They wanted warnings, they wanted information, but they also wanted it to look in a specific way. So basically not talking to people gets you something like this on the right, where what they actually want is like something on the left. And then this is something that happened really recently. So in one of our early studies, we talked about, well, implementing certificate validation for Android developers is maybe too hard. Maybe there should be a default, and then that should be configurable. And that's something that actually Android rolled out at some point. But what happened was that now, instead of people doing certificate handling themselves and they are messing up, they would just touch the configuration, and where they did would also overwrite secure defaults. And maybe a last slide on interesting future directions. So things that, should be studied, could be studied. If anyone wants to collaborate on this, be interested. As I said, documentation is really important, but it's usually created by the people who write, in our case, maybe the APIs, and they will often just say, we made this decision because of this reason, but they will likely not give fantastic code examples. So basically looking at which questions do people have online, which are the problems that they discuss, which are problems that end up in code, and then basically creating documentation specifically to address these problems would be something that would be awesome. Privacy is, I want to say, as important as security, but especially with developer research, it's kind of under-researched. Looking at a more diverse developer population for these studies would also be something that seems promising, right? Because as I said, a tiny minority of people are the ones that produce all the research and are also the ones that study basically their peers. So if we kind of take a look at the whole world and people who write code in other places in the world that are not Europe, not the US, we can maybe find like really interesting results or problems that they have solved or problems that we think we have solved and that they are not even aware of. And basically this requires not just Western researchers going in, but actually maybe having collaborations with people who are already doing the research in other countries on other continents, and basically trying to get our community to diversify and trying also to get the samples that we study to diversify. And then of course, one interesting thing is always, well, the security community develops cool things. How can we support developers in actually implementing these cool things that we come up with? And then usable crypto throughout the whole pipeline of basically theoretic awesome crypto to what end users use is something where across this like pipeline, a lot of populations are understudied. For example, API developers are understudied. So yeah, this is my talk. I hope it was interesting. I haven't looked at the chat window yet, but
thank you, Yasemin. So now we'll have the Q&A session and I'll try to moderate it. So please type in your questions, or you can also raise your hand in Zoom and we can unmute you and you can also ask the question directly to Yasemin. I can assure you there have been like lots of or several messages already exchanged and questions and discussion going on in the chat. So maybe I could take the first one from David already. So he asked, is there any way to detect code that was copied from Stack Overflow into production code base by, for example, by looking at for patterns with static code analysis tools? The only solution I can think of is to grep for Stack Overflow if developers are honest enough. And I think some people in the audience shared links to a couple of research papers, but maybe you can answer.
So let me stop sharing my screen so that I can try to find the chat also. So yeah, there's definitely research on doing this. There was one research paper that kind of like did this, but not in a way as like, here's a tool that does this. But there is actually, I think, like even years ago, there was an auto completion tool where people could basically start typing code, and then the tool would basically search Stack Overflow for, well, what do they likely mean, and then would kind of like help them by auto completing. So that was not designed for security. That was just designed for getting people quick results. But I mean, if you can do that for that reason, like, why shouldn't there be a tool, right? So basically the set of code snippets that have been on Stack Overflow is out there. there has been a paper by Felix Fischer in 2017 on basically this proliferation of, I think, insecure Android code from Stack Overflow into apps. So I think I don't know if it has been done in a in a production setting, but it definitely academically has been done, but without this like cool life detection and this cool thing where it's just like, oh, you copied this from the internet, check for security. And then also, well, if you do that, like what's the next question is like, what do you do with it, right? Like if you just tell the person you copied this, they know. Maybe it would be cool to automatically flag for code review, maybe by someone who knows more about security. So that's definitely interesting, and I'm dying to like click on the links and see what other people have done to solve this.
Sure. Thanks. I guess I see a few raised hands. So Jilang, do you want to unmute and ask your question?
Okay. Hello. My name is Dilang. I'm alumni from SECLO 2018. So actually, I have a question. Like the research basically now focuses on the internal aspect of the developers, like how they perceive or like how they seek out the answers of for secure programming. But is there any kind of research or like future directions where we actually consider the external factors, such as like from the stakeholders, especially for the executives who actually pushing the developers to actually produce some codes that actually like what they want, but actually not secure enough. So in fact, like the developers doesn't have any control over to make a more secure code. So therefore, like, is there any kind of like a study in the aspect from those factors?
You're muted, Yasemin.
Oh, sorry. Yeah, I'm aware of a couple studies that look at company culture, but I think every time we talk about secure behavior, where it's like, oh, individuals are making choices, we're really quickly crossing over into what is policy, right? There's basically like several different like layers of research questions. One is, the company wants everything to be secure. This is like how much time people have. And with the time they have, if we have better resources, they can have better outcomes without, investing more time, more effort, being more educated, and the whole process being more expensive for the company, right? So this is basically on the well, how can we, support these people level? But of course, this is a larger problem, and the problem is usually not developers being, stupid or lazy. And even with good resources, there's the point where it just costs money to do things securely, right? Like where the company either voluntarily or by adherence to laws has to make a choice, or has to be forced to make a choice that some things are going to just have to be done carefully, right? So I think there's like some reliance on, well, if there's a scandal where the company got dinged for doing something terribly and they're being breached, then people may, quit using products by this company. So there's kind of like a little bit of external pressure. And then there's also in some industries regulations, standards that companies have to adhere to. But basically, this is a question that kind of hints to, well, there's pressure on developers to get things done quickly, right? And yes, with tool support, this is something where we can help them, or with like better documentation, this is something where we can help them. But at the end of the day, someone has to go and invest effort into this problem, and that does cost money. And whether big companies like donate the money to research, or whether, I want to say, the open source community or like library developers invest the time to make resources more usable, yeah, but that's like also effort, and it also takes time, right? Or whether the companies go and say, well, security is important to us, and like we recognize that, you know, time to functional code or effort to get functional code is something that's like relatively cheap and can be done quickly, but we're going to invest in developer education and hiring experienced people and paying them appropriately, and also in having, you know, code reviews and trainings. So I think that just research can do so much, but at the end of the day, it's expensive to kind of invest into security, and it's a decision that has to be made at a level that's at some point is not the developer sitting there thinking, I have a deadline and the deadline is Friday, and I have to do this now, and I have to solve this, and you know, whatever works. Does this somewhat engage with or answer your question?
Yeah, it's kind of answered the questions. I mean, like I think it relatable to many, I mean, like many developers, because like most of them like getting pressurized by the higher ups, who actually doesn't really understand the importance of the computer security until accident happens, when they actually like got the fire burning already and that they have to extinguish it. But yeah, I mean, I realize that the issues may be like to match between the I mean, like because the research itself needs to be I mean, like the company needs to invest their money in order to apply this kind of research into practice. So yeah, thank you very much for the answers.
Welcome.
I guess Suresh, do you want to go next?
Yeah, hi. Maybe I think my question was already answered, but just like, so yeah, I was about to ask like how to handle a situation where I have a deadline, and then I'm able to make a functional code, but I'm not able to find the security. I'm not sure about the security of the code because I didn't find any good documentation, official documentation. So I was just thinking like, what if I'm ending up in such situation? So how to handle, like, is it like I just communicate to my company and my lead or my manager that this is how I did, or what's the best way to handle such situation, or just do it functionally and let it go? Or is communication necessary there?
I think this is a really good question. So I've never, you know, worked as a programmer in a company, but here's what I think, and this is just like my thoughts as a researcher. So if your company is one that communicates, you know, buy into security, and they say, well, this is really important to us, and like, you know, and you've experienced that they actually do care, they don't just say it, right? So, and then if you say, well, I need more time, or I need help, or I need more resources, or I need someone else to check this, or I need, you know, tool support, or we need a code review, and if we go live now, a problem may happen. And if this is a company that supports that, then it should be fine to communicate to whoever is the manager that there is a problem, right? But if you end up in a company where the culture is, we're going to do everything functionally and quickly, and then later, if we see that there was a problem, we're just going to fire one of the engineers, then that's maybe a situation where the environment just doesn't support security, where it's basically, well, if you have to deliver right now, and all you can get, like, either because you don't know how to fix this, or because there's not enough time or resources or whatever to, like, you know, to do it securely, where it puts you in an impossible situation, and where it's not where it's not something where you can just say, well, you know what, here's where I click and then I solve this, then this is just not something that you can fix at the time.
Yeah, I think the communication, being open would be good, and trying our best. Yeah. Thanks.
Yeah. Sid, do you want to go next?
Hi, Yasemin, very nice talk. My name is Sid Ravan. I'm a security researcher at Nokia Bell Labs, and I'm a doctoral candidate at Aalto University. And I'm one of those who got inspired by some of your works, and trying to do something similar of studying the developers with Janne Lindqvist and Gabriella, who's also on the call. So my question comes mostly from the like what method to study developers point of view. So the example what I have, or the question what I have is like, I see that you have 2 papers on cryptographic API and their warnings. So so the first one you use more like task analysis kind of approach, and for the subsequent, the second one you have used on this participatory design. So I just want to see what are the benefits of choosing one over the other, and is there any tip you can give for beginners on when to choose what kind of methodologies in general?
So I think the first basically big question is how much do you know about the problem that you want to study, right? So if you have a really clear idea of the problem that you want to study, and of the, maybe of the factors that may influence your problem to go in like a good or a bad direction, then you're basically set for like an experiment that you can do. But I think that's somewhat rare. So basically that you come in and you say, well, I want to test, like, is A better than B, or does A produce a problem or not, or solve a problem compared to B. So if you do have that, then it kind of makes sense to, design your study and just vary A and B and randomly assign people and then look at the outcome. What I would love to see more of is before people do that, like if they don't have a super clear idea, to not go and say, we'll just try this and see what happens, but to, take the time and ahead of the study, either do a qualitative explorative study where if the problem is not really scoped, you basically talk to people, which depending on where you are, could be colleagues, or could be an actual qualitative study that comes with questions that then kind of help you understand which are the problems, what kind of problem will I later be trying to solve. So that would be a good place for a qualitative study. Or even if you're like, well, what kinds of resources are actually being used, right? Like what is popular, so that, then I can kind of like look at which of these popular things does X or Y. Then it's maybe helpful to survey people first, right? And ask them, well, what do you use, or what do you like or hate about this? It's interesting now that Twitter, I think, is giving out their basically data to researchers. So if you're at the stage where you don't have like an A/B type problem, but where you're basically looking at what do people do, what do people say, it's also kind of feasible to, search through Twitter or search through developer forums online to get an idea of like what the scope of the problem is. And then that's research itself, right? It doesn't have to be an experiment where the outcome is like A or B. But then eventually maybe like one of the many things that you'll then find would basically narrow down to one of these experiments. And then if you do an experiment, it's also like, well, what do you care about, right? Like, do you care about how people engage with something? Then you would want to watch, right? So right now that's maybe not possible. So maybe you want to do screen sharing or screen recording in order to see what they're doing. But if you kind of like, you kind of know how people interact, but you just want to see the outcomes, then maybe like a remote programming study makes sense. Does that help at all?
Yeah, definitely. Thanks a lot for thank you.
Thanks for asking.
Sorry, I was muted. The next question is in the chat and you can read it. I'll still read it out loud for the recording. So Lucas asks, what is your opinion on more extensive regulation by law with respect to how companies develop software, hardware, where clear violations of certain best practices can lead to fines? He also asks if this recording will be available later. And yes, I can answer that it will be available later, but go ahead.
So, I mean, I myself don't regulate, right? But I have actually rarely seen a voluntary move towards something that's like more secure or more like privacy preserving, which potentially loses companies money. So what I've seen is that, you know, it seems like a competitive advantage, like everyone offers to have like private chat options, or everyone offers like this or that, so companies adopt it. But if you kind of like look at this like online tracking disaster, without any regulation, there's kind of like no change. And with regulation, people still try to, you know, get around it in the way that makes them the most money and also is like the least effort, and kind of like also annoys people into giving informed consent to like whatever. But I think if it's an engineering industry, right? And if we look into other industries and just imagine we didn't regulate them and we said like, you know, it would be really good if airplanes didn't crash, but if they crash, well, you know, so there's kind of, or like, oh, cars, it would be really good if the brakes work, but we don't specify, you know, you decide if you put best effort into creating cars with working brakes. So I think, and that's my personal opinion, but also an opinion that I have from, you know, talking to all these people. So if security is something that's not a hard requirement and a law can be a hard requirement, then it's maybe something that, as we also saw in the questions, kind of like moves towards the back of things that you may later get to, right? But if you create a situation where it's like, well, if we don't have security in these specified ways, and I know it's hard to specify security, right? But at least for like some things where it's like, well, you have to encrypt passwords at rest or like whatever. If we kind of, well, once you don't do that, you don't have a viable product, then there's just not going to be products out there that can exist without having this property. And of course, there's a discussion of like, well, what do, you know, small companies do that maybe can't cross this like digital security divide where it's like too expensive for them to do that. So that's basically, does that then, you know, promote third parties that kind of like offer the service and then make money off of these laws? Maybe. So this is basically, it does come with drawbacks also, especially for smaller companies. But we're not at a point, I think, where, you know, where small companies create these problems because they can't pay for security, but where large companies create these problems because they've done the math of like, it's cheaper to get sued for which is like really unlikely every once in a while than, you know, fixing this problem from the ground up.
Yeah, so sorry.
Go ahead. Yeah, go ahead. Please ask your question.
Yeah, hi, this is Lucas. Thanks for the answer. Yeah, and that is a kind of interesting thing. And I saw that Jack and some others also had the same question. It's kind of interesting to wonder how we can if we can have that kind of forcing function, because as you said, like we have the forcing functions in other industries like well, airplanes and cars and stuff. So like if we took the really most basic stuff, I guess it wouldn't even like kind of damage the small companies, but I don't know.
And then there's a trade-off, right? Where it's like, well, I don't know if this is a good thing, but small companies don't make cars, right? So I think, especially in the pandemic, we're relying on a lot of like software to go about our daily lives. And it's basically infrastructure that should be trustworthy. So it's the point where I don't know if like the big or small company question is the one that solves this, but it's actually, when I started this research, the security argument was also like always like, well, if you're not happy with it, then just don't use it, right? But now it's not feasible for anyone to opt out. So if you're not happy with the security, don't use it. It basically, it doesn't make sense, right? So it's something that basically everyone is forced to use at this point, where maybe you can make a couple choices between like different software, but maybe you can't, right? Like maybe your company says you have to use this software in order to work on this. So so then basically you can't make informed choices, right? So at this point, it's not, you can individually decide that you just don't use this and then you're not at risk. So yeah, as you said, right, like other industries are being regulated, and of course there are always problems with regulations that we would then also get. But you know, if I hop on a public train or if I get into a car, I can usually trust that, you know, the things that are the baseline for how this stuff should work, that they do work.
I'll still take one more question from Mikhail. He says, thank you for the fantastic talk. Has there been research on what makes Stack Overflow easy to read or easy to use? Is there anything that could be learned for developing official documentation?
So so not by us. I think there's anecdotal research out there, and like we've also gotten anecdotal results, or like qualitative results. I don't think if there's like a study that really, you know, asks like, why do you think this is good? But in the study where we compared stuff, where we compared different resources, people did say what they liked or what they hated. And then the other study where we compared crypto libraries and we talked about documentation, people also talked about what they liked and what they hated. So the one thing that people really liked was if it was searchable. So if you get an error, and then you can search that for that error, and then you will end up with a explanation or a solution. That's something that's really popular. And then what's also really helpful is, of course, use case based code examples, right? So the single like most useful thing would be, I want to do this, and the library clearly says it can be used for this. So there's like a configurable code example that I can just use. It already has all the good defaults and stuff. And then I just have to like plug it in and basically configure it a little bit. And I also get advice for how to configure it. So what I don't have to do is kind of like sit down and try to write anything from scratch. So that's basically what people go to Stack Overflow for. It's looking for code examples, and it's also looking for, I have this problem, I don't know how to fix this. And then this is where they get results. So basically that's what fantastic documentation should do. And then the idea would be that it's more useful than Stack Overflow, and that people would just, you know, stay there.
We have had like one of the longest Q&A sessions, so that just goes to show how engaged the audience has been. I'll take the last question. There was like lots of discussion on regulation before, but I'll take this last question from Abhishek, who asks, have nudge engines provided to be useful for usable security in the long run? Most papers which propose nudge engine for security problems report their results from study conducted in 1 to 3 months, showing that security choices improve during that period. Do people continue to use these solutions for the long?
That's a really great question, and I don't know the answer. What I do know is that people kind of at some point, so there's basically two options of like what can happen with nudges, I think. One is that people fix their behavior, right? And like don't continue to like make the same mistakes or make the same choices that create the same warnings. So basically either there's like some sort of learning behavior, or at some point people become accustomed to the warnings or become fatigued and become annoyed, and then they at some point there's an overload. So I think the challenge for nudging is really to kind of change behavior in a way that people are not constantly being nudged, right? I think there's like I want to say like a small window of time of like where people are constructively engaging with them, or maybe like for each problem they are constructively engaging with them. But if you basically, if a person continues to like make the same mistake and then gets the same warning or gets the same explanation over and over again, at some point, either, you know, they automatically kind of like go to the fix, or they learn, or at some point they learn to just ignore the problem, which is, it's really hard to do academic longitudinal studies of tool use, I think. It would require to work together with a company who was like rolling out, selling, maintaining, and creating good usability for the tool in order to try it to do a longitudinal study on that, right? Because I mean, in academic research, the prototypes that we create for people to use are usually not something that we can maintain for them to use for like 3 years, and then that we can observe for 3 years, and then that are usable for 3 years, right? So this is maybe a collaborative project waiting to happen that kind of like needs a crossover with industry, where a tool is already being used and where then telemetry data can be collected.
Okay, I guess I would like to stop more questions. It has been like half an hour. I think, Nina, you can stop recording. I don't know if I want to